Equivalent classes. An equivalent class is a set of inputs that are treated the same way by the software under certain conditions. In other words, under certain conditions, the software must apply the same logic to each element of the equivalent class. The ShareLane PM, Linda, wrote a spec about the feature that gives discounts to those customers who buy many books. Here is the table from her spec. We can immediately detect two spec bugs. One, it's not clear what discount rate should be applied if the number of books is exactly 50, 100, 500, 1,000, 5,000, or 10,000. For example, the value 50 belongs to two baskets. One basket has a discount rate of 2% and the other is 3%. 2. The table is not complete because it's not specified what happens if we have fewer than 20 books. Logically, it must be 0, but it makes sense to have that basket in the spec anyway, just to make sure that we have a complete list of inputs. We discovered those bugs during our spec review and sent an email to Linda requesting that she fix them. Here is how the table looks after the fixes. In other words, we have 8 equivalent classes. Each value inside a given class, for example class 2, must be equally treated by ShareLane software. For example, if one user buys 21 books and another user buys 43 books, they must each get a 2% discount because those values belong to the same class, class 2. Each class has 2 parts. 1. Range of inputs, for example, 20, 49 inclusively for class 2. Logic for output, for example, Class 2 inputs are treated with a 2% discount. Brain positioning. It is also very important to understand the critical role of conditions. In our case, everything is simple. We only care about how many books are purchased. But what if we are going to give discounts to users from the US only? In that case, our set of 8 equivalent classes would make sense only under this condition. Checkout is made by a user from the US. Other conditions would bring to life other sets of equivalent classes. For example, the condition checkout is made by a user from outside the US would give birth to a set that consists of only one class. Class 1, 1 or more books, discount is 0%. So what's so cool about equivalent classes? When we divide inputs into equivalent classes, we can clearly see the connection between the ranges of inputs and the logic of the code. Apply the technique called boundary values to select a small golden number of inputs out of the enormous number of possible inputs, and use that small number to hit the software in places where it's likely to break. Boundary values. Look at the picture below. The dashed vertical line is the first value of the class, lower boundary. The solid vertical line is the last value of the class, upper boundary. This picture is also available inside File, Boundary Values. For each equivalent class, we have only 1 out of 3 possibilities. 1. There is only a lower boundary, class 8. 2. There are both lower and upper boundaries, classes 1 through 7 inclusively. 3. There is only an upper boundary. We would have that class if we had a class unrestricted by a lower boundary, for example, any value below 1. The boundary values technique relies on the idea that software tends to break at the upper and lower boundaries of equivalent classes. Here is the full version of boundary values technique for one equivalent class. A. First, we test the lower boundary of the class, if the lower boundary exists. B. Second, we test the upper boundary of the class, if the upper boundary exists. C. Third, we test any value inside the class, if the value is not equal to lower or upper boundary of that class. Otherwise, we'll have a duplicate test case. D. Fourth, we test the upper boundary of the class that precedes the tested class, if the preceding class exists. E. Finally, we test the lower boundary of the class that follows the tested class, if the following class exists. Here's the same thing in the form of a table. This table is also available inside File A to E table. A, B, and C are positive tests. D and E are negative tests. You'll do comprehensive boundary testing using A, E table during your homework. Please open up File EC for discount functionality to see a set of inputs for performing boundary testing on all equivalent classes for discount functionality. We have 23 test cases to cover, 7 closed, each of classes 1 through 7 inclusively have both lower and upper boundary, and 1 open, Class 8 has no upper limit equivalent classes. There are 2 very cool facts here. 1, we covered an unlimited number of inputs with 23 test cases. 2, we used a methodology that hits the software right at its breaking points. Now, what if we wanted to test Class 2 in isolation? We would need 5 test cases. We've used the most advanced examples to learn boundary values technique. Now let's see how simple this can really be. Example: as you recall, a zip code must consist of 5 digits. Let's apply the A to E table. A 5, B 5, C 5, D 4, E 6. Therefore, we have only 3 test cases. Input 5 is positive testing. Inputs 4 and 6 are negative testing. Because the equivalent class is closed and consists of only 1 member, 5. When you start to implement testing techniques, here is a very important point to conclude our talk. The tester should be a master of testing techniques, not their slave. When you start to implement the black box testing methodology that you've learned, you'll probably feel frustrated, and in some cases you might start to think more about the implementation of methods than about finding bugs using those methods. To avoid that, you need a lot of practice to get up to speed with each method. In other words, you must become an expert in each of them. Remember our example with chess. The rules are simple, but walking the walk is not. So practice a lot. You'll have ShareLane and Test Portal for hands-on experience, and you have all the necessary theoretical knowledge to start practicing and become experts in the black box testing methodology. Lesson recap. 1. An equivalent class is a set of inputs that are treated by the software the same way under certain conditions. In other words, under certain conditions, the software must apply the same logic to each element of the equivalent class. 2. An equivalent class can consist of only 1 element. 3. Boundary testing checks certain points inside of equivalent classes for the purpose of detecting buggy parts of the code. 4. A to E table allows us to test 1 equivalent class. 5. Once we introduce conditions, for example, only U.S. users get a discount, we add more equivalent classes to our testing. 6. Testing techniques make up your toolbox. Use whatever you need from that box to find the best test scenarios. Creativity and practice are the keys here.